Hello everyone, this is Sai Kiran, pursuing third year BTech Information Technology at Gokaraju Rangaraju Institute of Engineering and Technology. I would like to present my project that is mood based food recommendation using machine learning. So let's have a look into it. As we all know, food and mood are closely linked. When we feel happy, we might crave for some comfort foods like ice cream or pizza. Same for different moods as well. This project is based on this interesting fact. This project uses machine learning to predict what kind of food a person is likely to have based on their mood. This system uses k-means clustering method to cluster food items into different categories, and also k-means clustering method to cluster restaurants as well. This system was trained on a dataset of food preferences called food choices, which is a surveyed data by students, and also another dataset called Zomato dataset to cluster the restaurants. The system was able to predict food choices with high accuracy. This suggests that it could be used to improve client satisfaction in the food and hospitality sectors. So let's have a look at the existing systems. One of the famous existing system is Modi Foodie model, which predicts the food based on the user's input mode. But this also comes with drawbacks, which is what we are trying to overcome. So let's have a look into this drawbacks called as like lack of context. Mood-based food recommendations often rely solely on the user's stated mood without considering the broader context. Like for example, a person who is feeling stressed after a long day at work might have different food preferences than a person who is feeling stressed because they are going through a difficult time in their life, and also limited emotional understanding. So let's see how our proposed system overcomes these limitations. Firstly, we train our model by using two bulk datasets, that is food choices and Zomato dataset, as I have mentioned earlier. We train the model using k-means clustering to cluster the restaurants at a given location, and also the food choices as well using k-means clustering. When the user inputs the current mode of the user through the user interface we have created by using Flask as frontend and Django as backend, we interpret and pass the mode to our model where it analyzes the mode and gives the recommended food choices and clusters the restaurant at a given location and shows them to the user ordered by their average aggregate rating. Now let's have a look into the activity diagram. When the user inputs the user's current mode, the model predicts the comfort food choices and clusters the restaurant by location, making the food and restaurant recommendations. Restaurants is recommended by average aggregate rating as I have mentioned earlier. Same with the use case diagram. We have user, developer, and ML model. User accesses the application, that is the user interface we have created, by selecting the mode. Developer has access to the dataset and he trains the ML model which is connected to the user interface. He creates a website as well using Flask. ML model makes the prediction by which it has been trained before, and entirely these all combine and display the food recommendations and restaurant recommendations to the end user. Now coming to the class diagram, we have data collection, data pre-processing. We train the data using the data set and the data which we have pre-processed earlier. When we train the data set, we make a prediction and food recommendation to the user. Now let us come to the crucial implementation part. So there are steps in the implementation which we all know, like uploading the Zomato and food choices dataset. We pre-process the dataset like improving the outlier and noisy data, removing the null values in the dataset, etc. Training the ML model using the k-means clustering algorithm, creating the user's interface, input user's current mode through the interface, and make the predictions. Now let's have a look into the code. So we have different files here like mode based food recommendation. This is our main ML model. We have app.py. This is the backend of our web app. This is index.html. This is a Flask file to show inputs to the user. This is result.html. This is also a Flask file to show the restaurants to the user. So these are all the necessary libraries for our model. We have imported them. This is where we load the dataset for our restaurants. This is where all the pre-processing is done. We remove the latitude and longitude of a place which is equal to 0. This is finding out the best cousins at a given place. This is where the k-means clustering starts for our restaurants dataset. As you can see, we have 7 clusters with 6 having the maximum data points and 3 having the lowest data points. This is where we load the food choices dataset for predicting the food for a given mood. This is calling that function by different moods. We get top 3 popular comfort foods for a given mood. Now let us have a look at the user interface. This is a Flask app connected to the model. Let us run the server. As you can see the server is already running at port 5000. Let us have a look into it in the web. So this is what the user interface looks like. We have used Tailwind CSS and Bootstrap as well for UI. These are the 9 different mode recommendations by our model. If you feel like any of the mode here, just click on the card and you will get the appropriate restaurant recommendations. Like you can see, these are the 9 restaurant recommendations ordered by average aggregate rating by our model. If you feel like watching TV, if you click on this card, you will get the appropriate recommendations as well. Pretty straightforward. Last but not the least, I would like to thank my team members Medikonda, Niklesh Reddy, and Puttabatini Sai Shashank for their immense contribution in the project. And I would like to express my sincere gratitude to my project guide V. Shailaja ma'am. Thank you.